Right. For a couple of days, we have been learning the attributes of BGP, which makes this protocol very special. No other protocols have got this level of tuning the path using attributes. Why it is so important? Because we have policies. Best is using BGP because policies are important for us and not that easy to configure policies in other protocols with a simple metric. That is why we need this BGP. That's the simple metrics of OSPF or EIGRP or ISIS or RIP cannot support you to apply the policies that we have in path selection. So this attribute, we are spending many number of days on this topic because this is the main topic in this protocol, attribute. Now, this page explains that. What is forwarding table? The table that will be referred by the router to take forwarding decision. That's called forwarding table. BGP's forwarding table is which one? When you type show IP BGP, we see a table, right? This one. This is the one. This is the BGP's forwarding table. Whichever the path that BGP has elected as the valid and best, only that will be installed into the routing table. For example, 10.97.97, though it has got two paths, in fact there are three paths, but it is coming from same IBGP neighbor via two different paths. That's why it's repeatedly having same next hop address, but actually physically it has got two paths. This router is what you are referring. You are checking this, and this is the router which addresses 172.31.11.4. It is giving in two paths. That is why you see two times. And if you notice, these are all same. So, though you have three paths, the forwarding decision is based on this table. And the path with this next one, and this path, AS path, is what the routing table is going to have. Routing table is going to have this destination and this as the next hop. And BGP table says that if you take this next hop, this is the path the packet will traverse. And if that is your policy, you leave it default. If not, you go and change weight or local preference and so on. So by tuning the attributes, the forwarding table is going to shift from one path to another path. And the path that is elected as the best is the only path that is going to be there in the routing table. Okay. Now you see here, the BGP's forwarding table usually have multiple paths. I just showed you three paths for that particular network, from which not all paths are elected. There is no load balancing because BGP is not designed to perform load balancing. See, it doesn't mean that you cannot do load balancing in BGP. By default, no. Because BGP is a protocol that works in border, we need more focus on policy, not on any other aspects like load balancing. But if in case if you want load balancing, it is possible. But by default, it is not supporting load balance. We have to do something manually. Let's not focus on load balancing now. As it is said here, we will take it. BGP is not designed to perform load balancing. BGP path is chosen based on policy. The path is not based on any other metric other than the attributes that you are tuned to meet the policy requirement. It is not based on any other metric like bandwidth. Not. So, even if you have multiple paths, BGP using attribute, it does the iteration against the list of attributes until a single best path is left. It will eliminate all other paths. BGP selection process eliminates any multiple path through iteration. Very, very important thing, you know. You cannot say, hey, such a big protocol, how can it be only single path? See, because it is big protocol doesn't mean that it needs to do load balance. What is the purpose? Policy. Then why are you talking about load balancing? If your policy is load balancing, then you do manually and tell the protocol, I want this. BGP will not do anything by default which you have not told. That's the security guarantee it gives. It is good. Unless you tell, it won't do anything. That is BGP. Okay. BGP selection process eliminates any multiple path through iteration. சல்லடை போட்டு சலிச்சு எடுக்கிறதுன்னு சொல்லுவாங்க இல்ல அதான். You know, filtering through filtration until a single best path is left. It will filter. According to this attribute, I cannot use this path. According to this attribute that is tuned by the owner, I cannot do this. Okay, now there is no tie. I'll use according to this attribute this path. That single best path is left and placed into the routing table. See, it is given to the routing table manager. Again, very important point. Manager is the final decision maker. It is given to the routing table manager. Now the routing table manager will process it, evaluate it against the methods of other routing protocol for reaching the network, say for example, administrative distance. The routing table manager is the final decision maker. Because it is given by BGP, it is not going to be giving more weightage. Routing table manager won't give more weightage because it is given by BGP. It will give importance if administrative distance is lower than any other source for the same destination. In case if there's a static route for the same destination which BGP is giving, which one should follow? Static route. Administrative distance is lower. So see, the BGP gives, routing table manager says, no, sorry, I can't use this. It's a RIB failure. Routing information based failure, meaning what? The routing table manager is not ready to use this BGP preferred, BGP's recommendation. So whatever the policy you may set, whatever the tuning you may do, the final decision maker is administrative distance. It's the routing table manager who is going to check for this administrative distance. If there is other protocol like OSPF whose administrative distance is 110, whereas IBGP is 200, if OSPF have got same network, OSPF path is going to be now considered. So the default routing table manager process is still honored. It is not overridden. The last point, the route from the source with the lower administrative distance is installed in the routing table. Now this is the sequence in which iteration, filtering, selecting one single path happens. First thing, considers only synchronized route. What is synchronized route? Valid and best. Meaning it should have a reachable next hop. If the next hop itself is unreachable, there is no use of going through these 11 attributes. So very important and zeroth attribute that is considered first is the valid next hop. The valid next hop. If I have multiple paths which are synchronized, meaning with valid next hop, synchronized, only then it will check whether one of this neighbor have high weightage. I told you, if you have multiple paths, very important, and that too they are synchronized. All the paths have got synchronized, meaning it has got a valid reachable next hop. Only then it will see whether any one of this neighbor in the paths have got high weight configured. We can configure weight. We learned about weight attribute. Weight attribute is local to the router. Please remember, try to recall attributes, weight. We learned that weight is local to the router. It is effective only on the router where you configure. The default weight is 0, and this weight attribute is not advertised to any eBGP or iBGP neighbor. It is local to the router. If you have the high weightage set, for any of the neighbor, then that neighbor path going where that neighbor is the path elected. For example, you see here, for the local network, it should not go to a neighbor. That's why high weightage is automatically, dynamically applied when it is a directly connected network on this router. On this router, this is physically or on the loopback interface, or somehow it is configured, and it is also coming from another neighbor, the same network. Should I go to another neighbor for my own network? No, no, no. You see, weight matters. Weight is the very first attribute. This origin comes even after AS, shortest AS path. Local origin comes after, you see, after local preference. Sorry, origin code only comes after AS. Don't get confused. This is origin code, whether it is distributed or advertised. Now we are talking about local origin. Local origin comes only after local preference. We are now dealing with weight. This itself is a tiebreaker. It need not to come here. If the next stop is this, automatically 3, 2, 7, 6, 8 will be assigned for the network. So that you no need to check the local preference or any other attribute. See, in this case, in the example that I showed you, weight is automatically coming because of BGP design if the next stop is 0.0.0.0. But what I'm trying to say here is you can also configure weight. The default is 0. High weightage is preferred. The neighbor to which you give high weightage is preferred. I want to show you this in the demo, then we will get into next attribute. You see this example here. The 6 has got two paths. One via router 3. See, to go to 666, router 2 says I'll go via router 3. The reason is only 3 hops. 1, 2, 3. Sorry. 1, 3000, 5000, and 4000. It says to go to this network, I'm going like this. One hop. This is same hop, same autonomous system. So that is not considered as a hop. Router is not considered as a hop. It says I go this way so that I will see 1, 2, 3 hops to reach. But if I go this way, it is more than 3 because someone has added. See, 2000 how many times? Literally there is only one 2000, but we have something called AS prepend. I'll be teaching you later. Because of that, this route looks bad now. This is like 4 hops. It is like 4 autonomous systems. But in reality, it is only one. It's tuned like that. 4 plus 1, 5. If I go this way, 5 hops. If I go this way, only 3 hops. So it says I'm going via this way because this has got less AS hops. Less AS hops. Only 3 hops. Less AS hops. Fine. How can you make the other path to be elected? Even though this has got more number of hops, if you tune weight, you see, weight comes before AS path is only on 4th attribute. So if I will configure weight, I can make the path to be via router 4. Even though it is looking like a more number of hops, I can still go via router 4 by tuning weight. Let me do and show you. You see right now, show IP BGP 6.6.6.6. It is very clearly saying I am going via router 3 because it is only 3 hops. I'm going via router 3. I'm not going via this path. This is not seen as best. It is an external neighbor eBGP, but it is not seen as best because of more number of AS. Though it is internal, it is considered as less hops, 3 hops. It is considered because of less number of hops. But we are going to configure weight. The current weight is 0. We are going to configure weight and change it. Let's do it. Router BGP 1000. Whatever you learn from neighbor 24.4.0.4, that has got weightage of 50. What is default? Default is 0. See, I have given weightage 50 here. Now let's clear IP BGP star soft. Whenever you change attributes, you have to clear. See, router 2 has got 2 neighbors. One is this guy, another one is this guy. It is learning from both 3 as well as 4, but I have given more weightage to this guy. See what happens. Show BGP. Now, because you said high weightage, whatever that is coming from 4 is considered. Earlier, this was having the greater than symbol. But now, the best is the longest path. It is because you have set weight. See, weight is an optional attribute. Optional transitive. See, the weight is not shown in this list. And few minutes before, when we were checking, it was not shown as the one of the attribute here anywhere. You don't see weight, the word weight, because only when you configure it will come. But that is not the case with the metric MED. Whether you configure or not, it is mandate. Okay, weight has come down. Now check the routing table, show IP route for 6.6.6.6. It will have next stop as router 4. It says the route given by BGP external is considered. But before setting weight, it was not like that. Let me remove the weight now. All right, now check the routing table, show IP route. Now it shows I'm going via 3 internal. You see, even in the routing table, you can see the impact. Show IP route. You can see for 6.6.6.6, it goes via 3. When the weight is not present. When we put weight, when you put weight for same 6.6.6.6, it's now going around. Is the weight attribute clear? Okay. So the default is 0. Highest weight is preferred. You can set any number of any big size weight. The default is 0. To question mark, it will be like 65,000, some big number is the maximum. Now, what is the difference between weight and local preference? Local preference is advertised to every router within that same AS. It is advertised to every router within the same AS. So that every router will take the same exit. We saw that in the examples, the theory class. Now let's see a demo. I will remove the weight here, which I configured here. Because if weight is there, local preference will not be effective. Why? Why local preference won't be effective if the weight is there? Because it is in the top. So only when there's a type, it will come to next attribute. Only if there's a tie, it will come to the next attribute, local preference. That is why I removed weight by BG. Now you see for this and this, for both, the weight is a tie. And the local preference, this is EBGP. EBGPs, they don't advertise local preference. That is why you don't see there. To check local preference, the best place is go to R1, show IP route, show IP BGP. It says, I'm going via router 3. I'm exiting via router 3. But if you prefer to exit via router 2, what I have to set on router 2, I need to give high local preference like this. Let me do and show you. After I do, you should not see 333 here. Okay. Right now it says I'm going via router 3. I go to router 2 and set high local preference here. Like this. Router BGP 1000. BGP default, this is the command. Local preference 101. See, router 3 is 100. By default, all router will have 100. Router 3 is 100, which was currently in use, but now I have made router 2 as 101. Which one is currently now in use? It's going to be router 2. Clear IPBGP star soft. After I issue this command and refresh, go back to router 1. Earlier it was going via 333, but now it goes via 222. It is because of the high local preference. Going via 3 is 100. Going via 2 is 101. So not only router 1, even router 3 will go via router 2. Show IP BGP. Even router 3 is going via router 2 only because of high local preference. Is this clear? Local preference. I recommend you to do this 2 laps.